Hello everyone, welcome to my machine learning with Python and TensorFlow. So I want you to hit on the Python navigator, and when this is done, we're going to load something called Jupyter Notebooks. So wait for this to initialize, and then we're going to hit Jupyter Notebook. So Jupyter Notebook is basically just another IDE. However, you'll see in a bit, it's better for individual code. So this is Jupyter Notebook, and it scans your computer for all of its files. So you might have the same name, like desktop and documents, but they'll probably have different values, different stuff in them. So I'm going to go to get my lessons. I need this one, that what we're doing today. And then I'm going to go to this one. And you simply, to create a new Jupyter Notebook, press New in Python 3. This should come pre-installed with Anaconda, so you shouldn't have to work too hard. And I'm going to title this whatever you want, so Lesson 1. Rename. Alright, so this is a cell. So to make a comment, you simply do Shift and 3, so you get a hashtag. Hashtag is for comments. And you can press Enter, so press Enter in a cell to make more lines. So, like so. Basically, you could write all of your code in one cell, but you probably shouldn't do that, and for reasons that will appear soon. So I'm going to do Shift-Enter to run this line of code and make a new cell. So because this was just comments, nothing would happen. And to save your entire... So a kernel are all of these cells. So this is cell 1, this is cell 2. A kernel is made up of multiple cells. To save a kernel, simply come here and hit Save and Checkpoint. To add a cell, just hit Insert Cell below. And you can, of course, drag and drop, I think, or come up here and move the cells up and down accordingly. So in this Jupyter Notebook IDE, you can simply write code just like you would anywhere else. So I do print hello, comments, hello world, Shift Enter, and this is the output. And I can put multiple commands in here, like Control V, and it just gives me the same output. So now, TensorFlow. So what is TensorFlow? So TensorFlow is a Python package that allows you to use machine learning modules and methods. And you can come here to the website to learn more. But to import it, you have to say import TensorFlow. And then that's Shift-Enter. And you'll see a star that runs this command. And that's how you know it's running but not completed. If you see a number, that means it successfully completed or ran the task you wanted it to do. So you see I have a 4, that means it ran. So to now get methods, I'll have to say TensorFlow dot and whatever methods there are. But that would be tedious, so we're going to say as tf. So now I can do tf dot and whatever methods that we'll need. And now I need to split my screen up. Right. Alright. And then I need something else. I need from TensorFlow import Keras. And basically what this is doing is saying from the TensorFlow module import only this function. So instead of tf.keras.method, I can just say Keras. And I think I'll need to import NumPy as NP. So basically, NumPy is a numerics library that will allow us to create arrays. So as in a video that on this website we'll have, the first example with TensorFlow is simply with data. So assume we had these following numbers. Copy. And these numbers as well. Control copy. So find the relation between these numbers. And what I mean by that is I want you to find an equation for these numbers, which does exist, and I'm going to let you know what it is. It is y is equal to 2x minus 1. And in some cases, it would be hard for you to see, but notice when x is 0, y was negative 1, and then you can just plug in the values randomly and you would get an answer. So this, x, and this array was y. So here x was negative 1, 0, 1, and y was negative 3, negative 1, and 1. So for a small sample set, you might have been able to easily see the relation. However, when this was way bigger, it would be much harder, and obviously some of you may have struggled not to even find this. But that's okay, that's okay. That's what we're going to use TensorFlow to find it. So we're going to create a model to find the relation between these values. So basically what we do is we create a variable that has one neural network that needs to output one y value for one given x value. And to do that, we say model equals keras dot sequential and parentheses. So notice that model, this name doesn't matter. This is just a variable, but for all intents and purposes, we're going to give it the name model. And then in parentheses, we have to say keras dot layers dot dense parentheses units equals 1 comma input shape is equal to brackets 1. And shift enter to run this. Layers is not defined. Oh, whoops, that should be a period. Alright, so that created our neural network. Congrats, you've just made it a neural network by one line of code. Congrats, give yourself a pat on the back. And then we're going to say model.compile parentheses. And now we need two important things you need to understand. The optimizer, space, and the loss. So optimizer is, so we need to compile the model. So optimizer makes new values. Loss tells us how good the values are. So basically, optimizer predicts new values, and loss determines how good those values are to make the next ones better. So the optimizer is, we're going to say, equals to SJD, and the loss is going to equal mean squared So you have to understand what the optimizer and loss are, but these values, SJD and the mean squared error, those are dependent upon the model you need to create. The optimizer and loss values will change depending on what you're trying to find. Here we're trying to find a relation between two sets of numbers, well technically one because we give it an x value. And so that is why we use the mean squared error. And you can Google the mean squared error on Wikipedia. Basically, it's a statistical thing that derives... it basically, if you find the regression line of an x and y values, and it predicts random variables using the regression line, and it finds the squared difference and mean between them to determine if there's a good enough correlation for a mean squared error. And basically, it determines, is this a big enough difference between the values to move on or not? And so I probably just butchered the explanation, but you can Google it for yourself. And so we're going to come back to here, and we're going to say model.fit xs for x series, ys for s series, or for the y series, comma, space, epochs, and then equals to 500, I guess. But there's a problem. The x and y's are not created yet. So here I'm going to move him down. So I need to create an x series with this values and a y series with these values, but I need to make them an array. TensorFlow only works with arrays. So I'm going to say x series is equal to np.array, parentheses, and then I'm just going to input this data. But now, an array, I need the same data type for each value. And we're going to set that equal to float. And then here, down below, y series is equal to np.array, parentheses, and now I just use these y values. Take note that the names of these series don't matter. It's what you put in them that matter. And we're going to say data type equal to float. And so now we should be able to run this. So we're saying here's the x array and here's the y array, and I want you to train the model 500 times to find the relation. So shift enter and runs it. Huh. X series is equal to data type dot fit x series. Huh, name xs is not defined. I don't understand. Model.fit. Oh, I didn't run this command. There we go. Sorry about that. And here we're going to see every time of 500 it was run. And so this is such an easy thing for even, the average computer. It did it in 76 milliseconds, I presume. And it shows me the loss, meaning this is the value of the mean squared error. The higher the loss, the worse it is, predicting-wise. You see every iteration, it goes down by a lot. And to where it's like just a small number. So now I can make the model give me a predicted value. So I'm going to say model.predict, parentheses, and in brackets, because remember, it has to be, you can't just put in the number 10. It has to be a float, and you need the brackets. And then shift enter, and it gives me 18.99. So is that true? Well, remember the function is y is equal to 2x minus 1. So if you were to plug in 10, you should get 19. And, well, that technically is correct. It's just the way the machines work. So 18.97 is correct. It's just how accurate the machine is. And we can, in fact, make the machine more accurate by doing this, by increasing the epochs. So I'm going to make it 900, shift enter, and then I'm going to say model.predict, and you see it gets closer to 19. So you can make it bigger and it would still get closer. I don't know if it would reach 19, but it means 19. And so make sure to look up the mean squared error. This is just one of the mathematical principles that powers TensorFlow. It's kind of crazy that TensorFlow has an equation to use the mean squared error in machine learning. So it's just kind of crazy. The mean squared error is kind of old mathematical theorem, but that's what it's doing to find a relation between numeric data. And so, yep. So this is, you have to notice, you have your data, you make it into an array, you sequentialize the model, you compile the model, you fit the model, and you predict the model. And so, yeah, that was my tutorial. Thank you.